Okay, we're going to talk about solving quadratic equations using the square root property. So the idea here is that what undoes the square, right? Well, what undoes addition would be subtraction. What undoes multiplication would be division. What undoes squaring would be the square root. So the square root of x squared is x. So we're using this idea to solve only a certain handful of equations. If we see that there is only a variable occurring one time and it's squared, I can undo the square using the square root. So the square root of s squared is s. The square root of 25 is plus and minus 5. So we have two solutions here. And we are going to put them in set notation. So we have -5 and 5. And then, of course, we can check them by plugging them in. So I have 5 squared equals 25. That works out. And -5, remembering to put parentheses around, squared equals also 25. So that one works out as well. Now, what our goal is going to be here is to isolate. First, we want to isolate the squared term. So we want to isolate t squared. To do that, we're going to add 90 to both sides. We get t squared equals 90. And then when we have the perfect square by itself, how do we undo the perfect square? Square root. Square root, square root. So t equals plus or minus square root of 90. Now remember that we also want to simplify if possible. So we're going to want to simplify the radical. Square root of 90 is the same thing as 9 times 10. So t equals plus or minus square root of 9 times 10, which becomes 3 radical 10, right? Okay, so this is our solution, plus or minus 3 radical 10. 3, because the square root of 9 is where we get the 3, so square root of 9 gives us the 3. A pair. Right. Since we have two of them, we're looking for a number times itself is the definition of perfect square. Yes, so 9 is a perfect square, and 9 is 3 times 3, so that's why the 3 comes out. And let's look at what the check would look like. So the check, I'm going to plug that back in. I'll plug in one at a time. So realize these are two different solutions. 3 radical 10 would be the positive one. Squared minus 90, is it equal to 0? So if I square 3, I get 9. Square the square root of 10, I get 10. Minus 90 equals 0. 90 minus 90 equals 0, which is true. Okay? So our goal is always going to be to get that perfect square by itself, that x squared. So here, just like as if we had 6x minus 30, we're going to undo everything to get that x squared by itself. So what would I need to do to both sides in order to get x squared by itself? Add 30. And then I get 6x squared equals 30. Now we want to divide by 6 to get x squared by itself. We get 5. How am I going to undo that x squared? Square root. Take the square root of both sides. X equals plus or minus radical 5. Now, can I simplify the square root of 5 anymore? And we say no, because 5 is not a perfect square. 5 is prime, actually. It's only 5 times 1. So this is our solution. Let's put it in set notation. Negative square root of 5 and the positive square root of 5, or radical 5. And then our check looks something like this. I'm just going to show you the positive one for now, but or I could show you the negative. They're really going to be the same, because when you square a negative, you get a positive. So the check looks like this. Now, one thing to be really careful about is the order of operations. You want to square before you multiply. So what happens when I square the square root of 5? I get 5. Yes, 6 times 5. Negative times a negative gives me a positive. Minus 30 equals 0. 30 minus 30 equals 0. 0 equals 0. So that checks out. The same thing will be true if we use the positive one. Okay? So now let's go on to the next one. First thing we want to do, let's get the variable squared by itself. So divide both sides by 100. Z squared equals 3 divided by 100. And now we want to get z by itself, so we're going to use the square root. Square root z equals plus or minus radical 3. What would the denominator be in this case? If I take the square root of 100, I'm going to get 10. Okay, we were talking before about rationalizing the denominator. Here we don't need to rationalize the denominator because it is a rational number. Because I skipped a step in between. I took the square root of 100 is what gave me 10. Square root of 100 is what gives me 10 there. Okay, so again, we can put that number in set notation. So we have the negative square root of 3 over 10 and the positive square root of 3 over 10. And then we can check, okay, to save time, I'm just going to check one of them. So I'll check the negative. 100 times negative square root of 3 over 10 squared. Is that equal to 3? So the magic is in the squaring here. So we're going to square first. When we square this, I'm not sure what you mean. Yes, squared. So it's going to be, so if we did square it, we would have, well, we're gonna square it first. So we have 100 times square root of 9, right? Negative times a negative gives us a positive, so square root of 9 is the same thing as 3, right? Over 100 equals 3. Square root of 9 is 3. These hundreds cancel, yeah? So 100 divided by 100 gives us a square root of 9, which is 3 equals 3. So I'm saying it's not the same thing as a positive, but when I square it, it is going to become positive. So I'm just, because of space and time, I'm only checking the positive one right now. Or I'm sorry, actually I'm only checking the negative one. But I'm assuming because of squaring a negative gives me a positive, the positive answer is going to do the same exact thing, right? Okay. Let's go on to the next page. So we can use this principle as well here, because as long as we isolate the perfect square, we're able to use that square root to undo the perfect square. Okay? So we want to isolate, oops. I can't spell isolate. Isolate. It's been a long day, you guys. How do you spell it? Isolate. There you go. I did. I know. I'm a really bad speller. Okay, so minus 6. We have x minus 5 squared equals, what's 25 minus 6? 19. Excellent. And so at this point, we don't want to go through the process of foiling this out, setting it equal to 0, trying to factor. That's what we did back in 8.1, right? We solved by factoring. Here we want it, because we have this perfect square, let's use the square root property. So we get x minus 5, because the square root undoes the square, equals plus or minus square root of 19. Okay? 19 again is prime, so it's not a perfect square. It cannot come out of the radical. So what are we going to do to get x by itself? Yeah, add 5 to both sides. X equals 5 plus or minus radical 19 is our solution. 5 plus or minus radical 19. Okay, and if I plug this in to check, remember these are two solutions, so let me check first the positive. So I'm going to plug in 5 plus radical 19 for x. 5 plus radical 19 minus 5 squared plus 6. We want to see if this equals 25. So first thing I'm going to do is simplify inside the parentheses. What does that simplify to? Radical 19, right? So the 5's cancel. We have the square root of 19 squared plus 6 equals 25. Square root of 19 squared is 19. 19 plus 6 equals 25, so that works out. If you square a negative, if I put the other one in, I will have a negative here. If I square a negative, I will still also get a positive, right, when I square that negative. Okay, here, what do we want to do? We want to subtract 36, good. Now don't forget to bring that negative down, negative, because that's basically negative 1 times, right? 3t plus 1 squared equals negative 36. What could I do right now to, I don't want to take the square root of a negative. Why can't I take the square root of a negative? It's not real, right? We can't take the square root of a negative. So divide by negative 1 on both sides. Now that will make that positive. 3t plus 1 squared equals 36. So what should I do next now that I've isolated the square? Yes, I want to use the square root. And I get 3t plus 1 equals plus or minus 6. That's what most people commonly forget, is that plus or minus part. So this means I actually have two solutions. 3t plus 1 equals positive 6. 3t plus 1 equals negative 6. So I need to solve both of those. Since 6 is not irrational, right? 36 was a perfect square. I actually have a number here that I could keep simplifying. So let's continue to get t by itself by subtract 1, right? 3t equals 5. And then what? Divide by 3. So I have t, one of my solutions is 5/3. This is my solution here. I'm just running out of space. Minus 1, 3t equals negative 7. Divide by 3. And so our second solution is negative 7/3. So two solutions. Normally I'd write the solutions down below. And then with the check, even though it was a fraction, the check is not that bad, because if you notice, the value you're plugging in for t has a denominator of 3. Well, this is being multiplied by 3. So we can do our check would look like 36 minus 3 times negative 7/3 plus 1 squared. If I use my calculator or if I just do this by hand, I'm expecting this whole thing to equal 0. So let's just see if it does equal 0. So 3 divided by 3 here gives us negative 7. So we have 36 minus negative 7 plus 1 squared. 36 minus negative 6 squared gives us 36 minus 36, which equals 0. Okay, try it out for yourself with the 5/3, and you're going to see that that will end up being a positive 6 inside. When you square that, you'll still get a 36. Mic check, let's do that. We'll stop here and we'll pick